Howdy there, Mr. Sutton here with the AB Calculus 3-9 Extra Practice Number 4 solutions on tangent lines and higher order derivatives. On this problem, we want to know which of these is the equation of the tangent line for the graph of y equals cosine of x at pi over 2. So in general, we're going to start with the point slope formula, y minus y1 equals m times x minus x1. So we need to get a point and a slope to use this formula. Let's start with the point. So we already have the x value, pi over 2. To get the y value, we'll just plug this into the original function. So that'll be cosine of pi over 2, which we know to be 0. So we've got y minus 0 and x minus pi over 2. We still need the slope, though. To get that, we need to take the derivative of the function, derivative of cosine, which is going to be negative sine of x. And now if we plug pi over 2 into that, that's going to end up being, let's see here, negative 1. So now putting it together in point slope, we have y minus the y value 0 equals the slope of negative 1 times x minus our x value of pi over 2. Of course, that doesn't match any of the answer choices, so we're going to have to put this in slope-intercept form. To do that, we will distribute that negative 1. So we've got negative x plus pi over 2, and there's nothing to move over here. So we just have y equals negative x plus pi over 2, which gives us choice C. On this problem, we have a figure showing the graph of f prime, the derivative of f, and we want to know at which of those x values indicated in the graph is f double prime the greatest. Well, f double prime is the slope of f prime, so we're looking for the spot where the slope of f prime is as steep as possible in the positive direction. So we've got A, which is at least positive, and so is B. C is 0 and D is negative, so C and D definitely wouldn't be it. Between A and B, B is steeper, so the slope of f prime then is greatest at B, which is also choice B. On this one, the derivative of f prime, is given by this function, and we want to know at what positive value of x does the line tangent to the graph of f have a slope of 2. Well, the slope of the line tangent to f is given by f prime, the derivative. So we're basically just asking, where does f prime of x equal 2? Now this is a calculator problem, so we're going to go ahead and use the calculator to figure this out. So here I am on my calculator. I've entered the f prime function in y1, and I'm also going to enter 2 down here in y2 because I want to see where these two things intersect to help me solve this equation. And for the window, well, they said they want positive values of x. And if we look at the answer choices, we're going from 0 all the way to, well, less than 9 anyway. So for my window, I'm going to go from 0 to 9. And let me zoom fit this thing, zoom 0, and see what happens. All right, so there is our f prime being graphed out. And there is 2, the horizontal line 2. So now let me do second trace, and then option 5, intersect. And then just press enter, 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 close to that intersection. And that's about 2.287. So that's going to be answer choice C. On this epic problem, we're given a twice differentiable function such that f of negative 1 is 5, and the first derivative, dy over dx, is given by this formula. We want the value of the second derivative when x equals negative 1. Well, we've at least got the formula for the first derivative. To get the second derivative, we have to take the derivative of dy over dx. So d squared y over dx squared is going to be the following. So we need to use the chain rule here. We have 1/5 times something squared. The derivative of that is going to be 2/5 times the something to the first power. Now we have to take the derivative of the something of xy squared plus 4y. And when we're doing that, y is an inner function. We're basically using implicit differentiation here. So whenever we take the derivative of something with a y, we have to follow it with a tail of dy over dx. Now it gets even trickier because this xy squared is going to require the product rule. So I'm going to bust out the box and ribbon to help me with that. My factors are x and y squared, and the derivatives of those are 1 and 2y dy over dx. There's that dy over dx tail that we were talking about. So multiplying this out using the ribbon, we've got 1 times y squared, so y squared, plus 2x y dy over dx. And don't forget, we also have to take the derivative of 4y. That's going to be 4 dy over dx. All right, so this is a big mess, and we still have to plug a bunch of stuff into it. So we've got -1 for the x values. We've got 5 for all the y values. But what about dy over dx? We need something for that because that is its own variable. So to find dy over dx, we have to actually plug -1 and 5 into the dy over dx formula that they already gave us. So let's go ahead and do that. So we've got 1/5, and x again is -1. Y is 5, so we got 5 squared. And then we have plus 4 times 5, and that whole thing is being squared. So taking this one step at a time, inside we've got 5 squared, which is 25, times -1, that's -25. So that's -25 plus 20 is all -5, so we have 1/5 -5 squared. We do the exponent first, so that's 25 times 1/5, which gives us 5. All right, now we have enough to actually plug things into the second derivative that we just came up with up here. So second derivative evaluated at the point -1, 5, and we have this derivative of 5 coming along for the ride as well. That's going to be 2/5 times the x value -1, y value of 5, and that's being squared again, plus 4 times 5, another y value. And now we get some new stuff. This is 5 squared plus 2 times -1 times 5 times dy over dx, which we found to be 5, plus 4 times 5 dy over dx again. Whole bunch of number crunching going on here. So this first parentheses, this is, let's see, -25 plus 20. So we have 2/5 times -5. And over here, all this craziness, we've got 25. This is going to be -50, and this is 20. So let's see here. We have 2/5 of -5. That's going to be -2. And over in this big parentheses, this is 45 minus 50, so -5. So that's -2 times -5 for a grand total of 10, which is going to be the only positive choice, answer choice D. For this problem, we're given this crazy equation here, and we want to figure out which of these statements is true. So we've got at points where x equals -2, tangent lines are horizontal, y equals -8, tangent lines are vertical, and then the tangent line at -1, 1 has a slope of 1/2. These are all talking about tangent lines. So that means that we need to figure out the derivative of this equation up here. To do that, since it's impossible to isolate y in this one, we are going to have to use implicit differentiation. So going from left to right, differentiating y with respect to x, we're going to have 3x squared for the derivative of x cubed, plus 2y, and we have a tail of dy over dx using the chain rule because y is considered an inner function of x here. And then we'll have minus 12 plus 16 dy over dx equals derivative of 28. Since 28 is a constant, that's going to be 0. And now we have to get all the dy over dx's on one side and all the non-dy over dx's on the other side. So 2y dy over dx, that can stay on the left, as can 16 dy over dx. But 3x squared, that's got to move over to the right side by being subtracted. And we'll add the 12 to get it over there as well. At this point, since I have all the dy over dx's on one side, I can factor out a dy over dx. That leaves me with 2y plus 16 inside. And then if I divide both sides by 2y plus 16, like so, that's going to get me dy over dx. All right, so I have the equation for the slope of this curve, and it takes both x and y values. Now, to answer these questions here, they said option 1 here, where x equals -2, lines tangent to the curve are horizontal. Well, that's basically saying that when you plug in -2 for x, this whole fraction comes out to 0, a slope of 0, a horizontal tangent line. So let's test out if that's actually true. Now, to make a fraction 0, you have to make the numerator 0. So if I plug in -2 to the numerator, let's see what happens. So we have -3 times -2 squared plus 12, and we're asking, does that have a value of 0? Well, let's see here. This is negative 3 times 4, which is negative 12, plus 12 does indeed equal 0. So that's a yes for that one. Now for the next one, option 2, where y equals negative 8, lines tangent to the curve are vertical. Well, vertical tangent line would mean you have an undefined slope, which would mean your denominator was 0. So if I plug in negative 8 for y, does that make the denominator 0? Let's try it out. 2 times negative 8 plus 16, using the denominator here. That's negative 16 plus 16, which, yes, is 0. So that's another yes. And then finally, line tangent to the curve at negative 1, 1 has a slope of 1/2. So if I plug in negative 1 for x and 1 for y to this whole thing here, does it come out to 1/2? Well, let's try that out. So dy over dx evaluated at negative 1 comma 1. That's going to be negative 3 parentheses negative 1 squared plus 12 over 2 times the y value 1 plus 16. This is negative 3 plus 12, which is 9. Down here we have 2 plus 16, which is 18. And that does indeed reduce to 1/2. So it turns out, and that's a yes, so it turns out option D then, all 3 options are correct. For this problem, we have the point negative 3 comma 4, which we're telling us is on the curve defined by x squared y cubed equals 576. And I'm sure we could verify it, but I'll just take their word for it. So we want to know which of these statements is true about this curve at that point. And here we're talking about the first derivative and the second derivative, and in all these answer choices we're asking, is each of these things negative or positive? So let's go ahead and find a formula for the first derivative, and then we can plug in our point. So to get that formula, I'm going to have to implicitly differentiate, and I'm going to have to right away use the product rule. So here's my box and ribbon. I've got factors of x squared and y cubed. Derivative of x squared is 2x. Derivative of y cubed, that's going to be 3y squared times a tail of dy over dx. So remember, y is being treated as a function of x. It's considered an inner function in this one. So whenever you take the derivative of something with y, you have to follow it with a dy over dx to represent the derivative of the inner function y. Okay, so multiplying this out with the ribbon now, we have 2x times y cubed plus, this will be 3x squared y cubed dy over dx. And all of that's going to equal the derivative of a constant, which is going to be 0. At this point, it would be helpful to isolate dy over dx. So let me subtract 2xy cubed from both sides, and then divide both sides by 3x squared y squared. So there's dy over dx. Now before I plug anything into this, I'm actually going to take a moment to simplify this a little bit, and I've got a few reasons for this. It'll make the plugging in easier, but also just kind of looking ahead, I know I'm going to have to take the second derivative. So I don't want to be taking the second derivative of this monstrosity if I don't have to. Let's make it a little nicer to look at. So some x's can cancel out, leaving just one x on the bottom. And also these y's can cancel, leaving just a single y in the numerator. So this then reduces to negative 2y over 3x. And now, plugging in negative 3 for x, positive 4 for y, let's see what we get. So that's negative 2 times 4 in the numerator, and 3 times negative 3 in the denominator. So that's negative 8 over negative 9, which reduces to 8 over 9. Now, the most important piece of this is that this is a positive number. Therefore, we've narrowed it down to answer choices C and D. Let's go ahead and take the second derivative now and see which one of these we have to pick. To take the second derivative, I need the derivative of negative 2y over 3x. And for that, I'm going to have to use the quotient rule. So let me bust out the box and ribbon here. So I'll be evaluating this eventually at negative 3 comma 4. But box and ribbon time, we'll get here in a minute. So we've got negative 2y, 3x, the denominator there. And now their derivatives. This is going to be negative 2 dy over dx. We still have to include that tail whenever we take the derivative of something with y. And then derivative of 3x is just 3. Now, I'm not going to multiply all this out quotient rule style right away. I'm actually going to plug in the point negative 3 comma 4 inside the box. And then I'll write it out all out over here. So let's see here. If x is negative 3, y is 4, and dy over dx is 8 over 9, negative 2 times y, that's negative 2 times 4. That's going to give me negative 8. And 3 times negative 3 is going to be negative 9. Negative 2 times my derivative, that's negative 2 times 8 over 9, so negative 16 over 9. And then finally, 3 is just playing itself in this motion picture. Now, for the quotient rule, I have to do u prime v minus uv prime all over v squared. So let me just follow the ribbon to write all that out. I've got a big fraction here, and I've got negative 16 ninths times negative 9. Negative 9s cancel, that's just going to be 16. Minus, now going the other way on the ribbon, we're doing minus negative 8 times 3, so that's actually plus 8 times 3, or positive 24. And then we're going to divide by v squared, so that's negative 9 squared, which is 81, for a grand total of 40 over 81. Now the important thing here is that this is positive. Since both the first and the second derivatives came out positive, that means we're picking answer choice D.